invited us to come over. I remember her saying that she's going to introduce us to something.
Okay, wait. Let me check my money first.
Wait, you put your cash in that big bag?
Yep, it's kind of a habit, using big things.
But is bigger always better? That's a good question. Well, that in all cases, the bigger is better. In the last century, the world has shown us that going small could have its benefits. An example is this. You can put your money in the small thing called pocket.
Whoa, you can put your money in that small thing? 5,000? Or 10,000?
Exactly. Wait, let me ask you something first. Where did you get this idea, Shilis? That's the reason why I pulled you here. Let me introduce you to the Nano World. The Nano World encompasses the study and manipulation of matter at the nanoscale, dealing with structures and phenomena at dimensions typically 100 nanometers.
That's kind of complicated.
That's understandable. Let me explain it to you in a simple way. The nano world refers to the realm of extremely small things, typically at the scale of nanometers or a billionth of meter. At this scale, we explore and manipulate materials at the level of atoms and molecules.
Well, we could say that the study of phenomena and properties of materials at a nanoscale, which called nanoscience. On the other hand, the applications of knowledge from nanoscience to create new materials is what we call nanotechnology.
So when you say nano, you mean something very, very small.
Yes, because nano means billion, so a nanometer means 1 billionth of a meter.
Okay, wait, one more thing. You kept mentioning this nanoscale. What is nanoscale?
Well, nanoscale is really, really tiny, like super, super small. It's the world where things are measured in nanometers.
Excuse me. I get the idea that nanoscale is a very, very small and that it needs nanometer to measure it. But what is nanometer?
A nanometer is a unit of length, and they are very, very small. 1 nanometer is equivalent of a billionth of meter.
Nanometers are like tiniest rulers splitting meters into billion equal parts. That's 1 nanometer.
Wow, that's small.
Yes, let us give you an example. We're gonna give you a different size of objects so that we can know how small nanoscale really is. First is 1 meter. An example of this size would be a human, just like Nino.
What? I'm actually 1.6 meters, you know?
Next is a phone. A phone size is 0.12 meters long or 12 millimeters. Continuing on a smaller object. That would be...
How about an insect?
That's a good idea.
An example would be an ant. This ant is about 12 millimeter long.
An object that is smaller than ants is hair. The width of a hair is 0.1 millimeters or 100 micrometers.
In the lingo of the nano world, we call micrometers microns.
Now we see a bacteria here, which is even smaller. This bacteria has been imaged with an electron microscope. A bacteria is about 2 microns in length.
Wait, so bacteria is 1 million times smaller than humans?
Yes!
So is bacteria the smallest?
No, bacteria is not the smallest. We still have virus and DNA. Right, Rialen?
Yes. There is an image of a virus. As we all know, virus is a cause of many harmful events. The weight of a virus is more than 30 nanometers, that's 0.03 micrometers, which is nearly 10,000 times smaller than the diameter of a human hair.
Lastly, we have here a DNA molecule with its characteristic helical shape. The weight of the DNA is 2 nanometers, which is about 1 billion times smaller than the height of human.
Just like what I said earlier, nano means billion. This describes feature sizes that are about 100 nanometer or smaller. An example of this would be viruses or DNA.
I see.
Well, let me tell you something fun. What if we go to the other side? Instead of 1 billion times smaller, what if it's 1 billion times larger? Can you imagine it? An example of it would be the sun. The sun in our solar system is about 1 billion times larger than the human height.
Whoa, that's cool.
Yes, so the comparison of the DNA and the human is the same as comparing us humans to the sun.
Oh, I see. Wow, this is really amazing. I wonder who started the concept of nanotechnology and nanoscience. That person must have been a genius.
Well, the one who coined this idea is Richard Feynman.
Wait, Richard Feynman? As in the physicist Richard Feynman? The one who discussed the method in which scientists can direct and control individual atoms and molecules?
You know him?
Yes, his famous talk There's Plenty of Room at the Bottom is well known.
I'm glad that you know him. Also, the term nanotechnology was coined by Professor Norio Taniguchi. Right, Professor Shilis?
Yes, that is correct.
Is it possible to find nanomaterials?
Yes, of course. Since there are nanomaterials that are naturally occurring, you can find those nanomaterials everywhere, in volcanic ash, ocean spray fine scent, and dust.
Whoa!
Naturally occurring nanostructures are also present in plants and animals. An example will be an insect's eyes.
Yes, you're right. As far as I can remember, the compound eye of an insect is composed of large numbers of identical unit eyes, each with its own lens and array of cell types.
Wow, that is really amazing, but how do we view these nanomaterials?
Well, we use special type of microscope to view nanomaterials. These special type of microscope are electron microscope.
Atomic force microscope.
And scanning tunneling microscope.
Electron microscope is a type of a microscope that utilizes a particle beam of electrons to light up a specimen and develop well-magnified image.
If I'm not mistaken, the electron microscope was built by Ernst Ruska and Max Nall, right?
Yeah, that is correct. If I'm not mistaken, there are two types of electron microscope. The scanning electron microscope or SEM and transmission electron microscope or TEM.
Yes, both of you are correct. And also the other microscope is called atomic force microscope. It makes use of a mechanical probe that gathers information from the surface of a material.
Oh, I remember who developed it. Wait. Gerd Binnig and Calvin Quate and who is it?
Christoph Gerber in 1986.
Yes, those three!
Lastly is the scanning tunneling microscope. This special type of microscope enables us to view and manipulate nanoscale particles, atoms, and small molecules.
Is there any development of new products and improved materials in using nanoscale?
Yes, it is called nanomanufacturing. It refers to scaled-up, retractable, and cost-effective manufacturing of nanoscale materials, structures, devices, and systems.
There is actually two fundamental approaches to nanomanufacturing, either bottom-up or top-down.
And what's their differences?
Well, the bottom-up manufactures products by building them up from atomic and molecular scale.
How about the top-down?
The top-down, on the other hand, trims down large piece of materials into scale.
Oh, I thought thought this was complicated things. Turns out it was really simple.
Yes, and also, do you know that nanotechnology have many advantages?
Oh, really? Like what?
Well, it has a positive impact on the environment, health, and the economy.
Oh wow, what are its benefits to our environment? I'm interested. In the environment, they're like the cleanup crew for environmental messes, making our planet a bit happier.
For example, in a dirty lake, they dive in and eat up all the bad stuffs, turning the water from messy to super clean.
Wow, that's amazing. How about its benefit on our health? Well, it improves medicine.
Absolutely. For instance, nanotechnology deliver medicine exactly where it's needed, fixing only the parts that needs fixing.
Oh, so that's why we get better quicker.
And the last one, we have the economy. Because of nanotechnology, we have better products and lot of job opportunities.
When we make things so small, they can work better and do amazing things. Also, we need smart people to understand and work with nanotechnology, creating new jobs and boosting our economy.
Wow, nanotechnology is truly mind-blowing, but does it have any disadvantage?
Sad to say, but yes, it has a drawback. Every coin has two sides.
Imagine what will happen when these nano guys start hanging out in our soil and water. We're not sure, and that's a bit concerning for our Mother Earth.
Then in health, we're not entirely sure how these teeny tiny particles in nanotechnology interact with our bodies. It might have harmful effects in our bodies. Safety first, right?
Oh my god, that's terrifying.
In the economy, let's just imagine that there is a toy company that makes super tiny robots. We can say that it is very expensive, those only a few rich kids buy them.
Then the toy company becomes very rich.
Then the other toy companies who make regular toys would struggle.
Exactly.
Ah, that's why it makes the economy unbalanced, with some companies doing well and others are not doing so great. That is why we must stay cautious and curious in everything.
I have an idea that nanotechnology is not just making things small, but also bringing ideas to make a better world in the fields of medicine and technology.
Yeah, you're right. Thank you so much for this new knowledge, Professor Shilis, Professor Ray, and Professor Nino. Thank you so much for bringing us to this world.
World? What world?
The Nano World!